All right. Sorry about starting a few minutes late here. Looks like we only have Prem at the moment. Prem, do you have any questions for me this week? Anything in particular you'd like me to go over, or any questions you have, or things you've been struggling with? As always, I've got a whole bunch of random things I can always go over, just extra little tips and tricks. Let's see what things I have in my list. Let's see. Okay. Prem had a very good question here. He wants to know about bullet ignore. And yeah, that's a very good question. I like using bullet ignore all the time to turn off pieces and create some secondary effects. So let's see if I can create a good example of this. I never want to spend too much time on the setup before getting to the actual content. Let's see, what could be a good example? I do like using bullet ignore for reshatter effects. Let's try doing that. We'll maybe do a basic glass emission. So let's just create, or let's just scatter a whole bunch of glass geometry. Let's make this box source a bit bigger. All right, I'm just going to I'm going to use a pyro source for this actually. I don't really use the pyro source for, actually sourcing dust or flames or anything. This is really just a convenient way of scattering points, because you can use either a surface scatter or a volume scatter here. So it seems like more of a general tool than specifically a pyro related tool. So also, sorry about all the camera flipping. I mentioned it in a forum post. I believe it's in the week 6 section. I've had to use a daily build of Houdini to get my flipbooks to work properly. But it seems like since I've been using this daily build, I get this weird camera flipping problem. So that's probably going to happen a lot in this session. I might try reverting to the latest production build to see if that fixes it. But for now, we're going to have to deal, unfortunately. So let's merge in our glass shards. I'll pull those in from week 7, glass fracture and out glass fracture. And we'll do our classic copy stamp setup for this. Let's do our randomize for the geom IDs. Actually, you know what? I'm going to just copy this from one of the other sections just to set it up a little bit faster. I'll just go into the shattered windows section, I suppose. And I'll just, copy the instances null. Actually, this whole section I suppose we can grab, just to get those window shards a bit more quickly than creating this all from scratch. All right. Type our points in there and see what we've got. Okay, we're going to make these a whole lot bigger. For a reshatter effect, we want to start with significantly larger pieces. So let's start with 0.5 up through maybe a value of 1. All right. Man, this camera bug is terrible. All right, now let's set up actually let's copy the name setup and everything for this as well. Leave this back on manual. And we'll grab the velocity, the W, the attribute promote, sim attributes. Yeah, grab all that good stuff. Maybe I'll even grab the .NET as well, even though we don't need all the stuff that's in it. So inside the .NET, I'm just going to get rid of these extra colliders for now. And let's rewind and see if we have something reasonable to start with here. Okay. I suppose this will work. Let's start by just choosing maybe half of these to reshatter on impact. So maybe I'll set a reshatter attribute on all of these points. And this is not, usually for this sort of thing, we use some custom tools at work. So I don't think I've ever done this in regular vanilla Houdini on regular DOPS. So this will be a little bit of an experiment. But yes, I'm going to just set a reshatter attribute equal to a test. I'll say random of ptnum is less than 0.5. So this will set a reshatter attribute on half of these. Let's just double check that. Yep, looks like about half of those are getting that attribute. Now we want to, let's see, trying to remember how to do this without the deneg tools. It's probably going to be good practice. Let's check the collision attributes available on the RBD packed object. So let's go to, I often find it easier to just pull up the Houdini docs in a web browser, since the Houdini help can be a little bit slow to load sometimes. It's a little bit silly that this is faster, but it often is. All right. Now, anytime you want to do some custom behavior in basically any bullet sim or pop sim, it's good to just check all the custom attributes that you have available. I'd encourage you to look through the particle attributes as well. They're pretty similar to the bullet attributes that are available. Particle attributes, Houdini. And so these attributes are all the various attributes you can use on your particles and your pop sims. So if you want to do something special or have really manual control over it, you can use this. Now, let's try you turning on the impact data. Normally, I don't get into the impact data in this class because it's kind of a bit more complicated and we don't have enough time in this 8 weeks to get into that. And for most things, you don't really need to use impact data. So it's turned on by default. You'll see that on the RBD packed object, there's this add impact data checkbox here. And if I remember correctly, we should be able to query this in a SOP solver. So let's drop in that SOP solver, and we're going to use a multi-solver to combine the bullet and the SOP solver. And let's connect our RBD packed object debris to that multi-solver. Oh, this is getting a little bit mixed up. All right, there we go. Just to make this a little more clear, I guess I'll delete these colliders. Yeah, whenever you're using a multi-solver like this, you just want to make sure your RBD packed object is connected to that and not to the bullet solver directly. So let's rewind our sim and go to an area where we definitely have some impacts happening. So it looks like there are some impacts there. So let's dive inside the SOP solver. And on the SOP solver, you see that you have a few different types of geometry available. Our DOP geometry is, the actual RBDs. We've looked at the relationship geometry quite a bit. The feedbacks I don't typically use for anything. And then the impacts should be all of our impact data. It's just when we display that, you can see we have all of these points along the ground here. Those aren't points to represent all of our objects. As you can see, we have all these objects here, but our impact data is just showing us points where those impacts are actually happening. So let's pull up the spreadsheet for this and see what data we have available. All right, so some of this impact data is not very obvious. So we have an impulse, which is basically the strength of the impact. The normal is just going to be, I assume, the normal direction of that impact. I don't know if it's takes into account the angle they're hitting each other, or if it's just, the surface normal of the thing it's hitting. But the key here is we want to know which objects are impacting. So you'll notice that the object name just shows our RBD packed object debris. And for the other object, it looks like we have two different values. So we have a value of 1 and a value of 0. Now, when I said some of this data is not very straightforward, what I mean is that you can't very easily tell which objects are hitting, especially if you have passive colliders in here. Let's say we had, a whole bunch of characters and a spaceship, and you wanted to see which objects your glass shards were hitting. You would have to do some kind of complicated things where you get the object name of, the object that it's impacting, and then this gives you the primitive number of, within that object. So for all of these debris collisions where the other object is 1, it looks like it's hitting another piece of glass instead of the ground. You can see we have these primitive numbers here. So we could potentially, look up if you wanted to tell which piece, if this glass shard was hitting this one, we could do some sort of a primitive lookup to say, everything that this piece touches, we want to turn off with bullet ignore. You have to do some kind of complicated matching of the prim number to the objects. I don't think we'll have time to do that. Usually you don't have to, but that could be interesting to look at next session. I'll take a look at it in this session if I can. But I'm expecting this bullet ignore setup to take most of our time. But anyway, you'll notice that some of these impacts are hitting object 0, and the prim num for all of those debris objects that are hitting this other object 0 are -1. And that's a hint that it's not hitting another RBD object in the scene. This is actually hitting the ground plane. So in this case, I'm going to have the pieces reshatter on impact with the ground. So let's detect that. Let's see, what's the best way to do this? Like I said, this is a little bit experimental because I've only done this with you know, some studio tools. So for each of these RBD pieces, we're going to query whether it is a part of a collision and the impact data here. So this is where I said it's not very straightforward. We have to figure out if there are impact records that match the current piece that we'll be checking. So let's see. We should have, so we have this other object primnum. Let's see if we have a current object primnum. All right, yeah. So there's this other object primnum, which has the data about the second object it's hitting. But we also have this straight primnum attribute data here. So I can say for each primitive in our DOP geometry, check to see if that primnum exists in the impact data records. So let's drop in a primitive wrangle. And let's connect the second input to our impact records. And then in our wrangle, let's create a float attribute, or an integer attribute rather, called check. Actually, let's call this index. And I'll say find attrib vel. Actually, we don't need to find the index. We can find the attribute value count. So the difference between these two vex functions is that find attribute value will return the indices in the DOP import records where this primitive number exists, whereas the find attribute value count will tell us how many times it exists in our impact records. So actually, you know what? Let's find the attribute values, because I'm going to try to make this a little bit smarter, because I'm going to set this up so that it doesn't reshatter when the glass shards hit each other. It only reshatters when it hits the ground. So if you want to see the syntax for find attribute value, you can click on it and hit F1. And then we can check the syntax here. So let's set this to always on top. So for this find attribute value, I'm going to use the array version lookup of this. So it'll return a list of all the indices where that primitive number exists. So we'll look up the geometry in input 1 of the wrangle. The attribute class is going to be point, because all of the data on these impact records is point data. There are no primitives here. And the attribute name we're looking for in our impact data is primnum. And the value is going to be the current prim number that we're processing in the wrangle. So we'll just type @primnum for that. And then this should give us a list of all the indices that in our DOP import records that contain an impact for the current piece. So right now, we could, just to check to see if this is working, we could store the length of this array potentially. So I'll set an integer num found, I at num found, equals, and I think the vex function to check the length of an array is size. I'm not positive. I feel like I should know this, but it's not. Let's go back to our vex functions, look at the arrays option here. Okay, to get the length of an array, it's len. different programming languages use different functions for some of this same processes. So len gives us the length of this index array. And what that's going to do is that'll tell us how many records it has found in the impacts that match the current primnum. So if we look at the spreadsheet for our wrangle, and if we look for this num found integer, so we're on the points, you have to go to prims. Okay. So if we sort this, you can see that this num found is returning the number of impact records for each of these pieces. So you can see half of them aren't impacting at all, and the other half look like they are. So let's perhaps turn them red if they're impacted. So I'll say if at num found is greater than 0, then we'll set a color at CD equal to 1, 0, 0, just so we can visually see those turning red if they've impacted. Let's see, oh, forgot my equal sign. Okay, so this is some pretty cool color feedback. You can see this detecting all of the pieces that have collided. So if we rewind and step through our sim here, and you can see those impacts happening in mid-air as well. And ultimately, we're going to want to ignore all of those mid-air impacts. We only want this to detect the impacts on the ground. So let's loop over, for each of these prims, let's loop over the found impacts to determine if it's hitting the ground or not. And like I said, we can tell if it's hitting the ground based on this other object primnum to see if this is equal to -1. So let's, maybe we'll do a while loop to check this. Or actually, let's do a for loop for I and index. Let's see, I forget if we can do it this way. I used to be much better at programming, but since we don't typically have to use a whole lot of it, at least we don't usually use very heavy stuff in effects most of the time. So if you don't know your programming very well, don't worry, because you'll pick up enough bits and pieces as we go. Let's see if I remember the syntax for this. I really should. So for int I is less than num found. Try that, and I++. Then let's just do some silly thing here. I'll say at CD equals some other color just to make sure this loop is working correctly. See if this works without errors. Oh, looks like a little typo here. I put in a comma instead of a semicolon. All right. Cool. So I've got these. It looks like I have the syntax working correctly for the for loop. Looks like I maybe have to initialize this. I equals 0. Okay. Now it's happy. Now let's find out. I'm going to comment out this num found. Let's try to detect if this has hit the ground or not. So we'll do a lookup for each of these indices. So what this is doing right now is for each primitive, we're getting all of the impact records for that current primitive on that current frame. Now, this for loop is going to loop over the impact records for each individual piece. So let's say the primitive wrangle is just processing this piece down here. that camera bug is terrible. I'm sorry about that. So we're getting the list of all the impacts for that. And now we're looping over all of those impact records in this for loop here. And we're going to check to see if each impact record is impacting the ground plane. So let's double check the attribute we're looking for. It's other object primnum. So let's get the primitive attribute. We'll use a temp variable, int other prim equals -1 for an initial value. And I'll say other prim equals this point lookup from input 1. And we want this other object primnum attribute for the current found hit record, which is going to be this index local variable we created, sub I. So this should give us the value of that primnum that it's hitting. And let's say if other prim is equal to -1, and that needs to be double equal, but then let's set this to red. And if you're just doing one line if statements, you can kind of stack them next to each other like this. It doesn't have to be on a second line. And let's say else. Then we're going to set just a different color. Maybe I'll set it to blue. Let's see what that looks like. Okay. So if we step through our sim here, we should be seeing only blue impacts in the air. So you can see how all of these impacts being detected are just blue impacts because this other object primnum that it's returning is an actual valid primnum from this RBD packed object for the debris. And once this starts hitting the ground, you'll see it's finding that value of -1 for the other object primnum. You can see it's starting to hit those here. So now we can tell which object we've hit. Oh, so I see there's a little problem here. This kind of works the way it is now, but as we saw when we were checking our spreadsheet for those impact detections, this num found attribute shows us that this has multiple impacts happening. So where's my spreadsheet? That's not the spreadsheet we want. Not the spreadsheet for the wrangle. Don't know why that's not popping up. That's strange. Anyway, let's go to the spreadsheet here. So if we go back to these prim attributes, you can see some of these objects are hitting, almost 30 times. There are almost 30 impact records here. So we want to find out if any of those have hit the ground. When we're looping over all of those impacts, the final color stored, that blue or red, indicating the hitting another RBD object or the ground, will just show us whatever the last impact was in the list. So we want to find out if any of those impacts are on the ground. So let's check this to see. Let's create an attribute saying hit ground. So let's say int hit ground will default to 0. And then we'll say if other prim is equal to -1, then we'll set at hit ground equal to 1. And then we can get rid of this check for the color for now. So now this is just going to check in our loop over all the impact records to see if this has ever hit the ground. So at the end of the loop, regardless of the order of those impact records, it should always tell us whether it's hit the ground or not. So let's maybe do a color if it has hit the ground. I'll just cut that color out there, paste that in here. And instead of if at num found is greater than 0, I'll just say if at hit ground. And since hit ground is just a 0 or 1 value, it's fine to just use that attribute like this without checking against 0. So now anything that hits the ground should be red regardless of the order of the impact data. And looks like we have a couple other people in here. I know that some of this is pretty complicated. Anytime you're trying to explain Vex code, it can be a little bit complicated to explain. So if anything is unclear that I'm going over here, let me know, and I am happy to clarify it. And at the very end here, I'm going to also just walk through our final Vex again, step by step, just to try to help drive home that description of how everything is working. But in any case, you can see that none of our pieces are being colored in the air, because despite those impacts, when it checks to see if any of those impacts are hitting the ground, that's never true, so it's never setting this hit ground attribute. Actually, it looks like I made a mistake. I set a local variable for the hit ground here, but then I'm using an attribute reference. So let's flip that to an attribute. See if that attribute is existing here. Okay. So now you can see our pieces are turning red once they've hit. And cool. Looks like that's working correctly. It's only detecting impacts for the ground. And once we detect that impact, now we're going to set that to bullet ignore. So right now we're saying if I at hit ground, then change the color to red. But in addition to setting the color to red, let's set it to red only if the reshatter attribute has been set to 1, since maybe we only want half of these to reshatter. So I'll say if hit ground and I at reshatter, and I'm just going to double check to make sure this reshatter attribute exists. One little trick that I just found out about is that I think this is a new 17.5 thing. If you middle click on any of these attributes in this info page here, it'll display that in the viewport, or it should. I think it's a middle click. Maybe it doesn't. Let's try this in SOPs real quick. So we've got this reshatter int. I just tried this at work. It was definitely working. Maybe we have to display that as full geometry. I won't mess around with this much longer if this isn't working. Let's display this, display the info for that. And, I guess that's not working. Maybe we have to display the points. Anyway, supposedly there's some feature And it did seem to be working at work where you could, I think it's a middle click, that would display visually those attribute values in the viewport. Anyway, going back to our .NET, let's focus back on the stuff that we are really interested in today. So if this hits the ground, we're also going to set this to bullet ignore. And like I said, I was just making sure that we have some reshatter attributes available in our solver here. So yep, looks like that is available, although the reshatter is on points and we're checking prims. So maybe just before the sim, I'll promote that attribute. Let's promote that from points to primitives. I'll select the reshatter. Go back down into the SOP solver and reset our sim. Now we should have, yep, we have reshatter available on our prims now. So this check against that reshatter attribute will work. So now you can see that it looks like about half of our objects are turning red once it hits the ground, only the ones that we've tagged to reshatter. Now, we also want to set these to bullet ignore. So I'll say I at bullet underscore ignore equals 1. And let's step through here. So it looks like the bullet ignore might not be persistent. Maybe we need to use the feedback in order for those changes to be persistent. That's my best guess. All right, so for this feedback, like I said, I've only used custom tools at work for this sort of stuff before. So hopefully I can get this working. Let's see if that object mask will just work with RBD packed. Because I can tell here that we are setting bullet ignore on some of these. Oh, I see the problem here. We're setting bullet ignore on all of the primitives. And any attributes that bullet cares about pretty much have to be on points. So instead of setting bullet ignore, I'm going to use an attribute called reshattered or do reshatter. So say I at do reshatter is equal to equal to 1. Or actually, no, I'll set a group instead. I'll do at group underscore shatter is equal to 1. So now when those things hit, you can see, or at least you should be able to see, yep, we've got the shatter group being created for those. And now that we have this group being created, we can use a point wrangle to set the attributes that we want. So we'll drop in that point wrangle, and this group dropdown will select that shatter group that we just created in our primitive wrangle. And there I'll say I at bullet underscore ignore equals 1. And like I always say, whenever you're working in solvers like this, you always want to make sure to set an output in case you put your display flag on something incorrect. You want this to always output the correct thing. But yeah, now with that point wrangle added, let's see if it's actually properly ignoring those pieces, which it's not. Let's double check to make sure some of these pieces are being set to bullet ignore. Yep. All right, so it looks like that's not persistent. Um, How do we make this persistent? This is the downside of working at big places. You get so used to some of the custom tools that when you try to do some non-standard stuff without your custom tools, you can be a little bit lost. I'm not sure why this bullet ignore is not persistent here. Let's check the help for our DOP SOP solver to see if that gives us any hints. Let's go here. Pull up the help for that. Let's see. Sorry if this is not the most exciting part to watch me hunting through the docs. I don't think this will make a difference. We could try changing the order of those solvers. Probably doesn't make a difference, but we can find out. Anyway, we should be able to do the reshatter even if the bullet ignore is not working. Let's see if we can tag this with the impact frame. So I'm going to set a default impact frame on all of our pieces. So on the sim attributes, I'll just say f at shatter frame equals 10,000. So it never shatters by default. And then let's go back inside our DOPNet. And on this point wrangle where we're setting bullet ignore, let's rewind this and see if that shatter frame is coming through on our DOP geometry. Okay, yep, looks like the shatter frame is there. And now we'll say that f at shatter frame is equal to the minimum between whatever that current shatter frame value is and the current frame now. Because basically, if this solver detects that the object shatters based on an impact, if there's a new impact later, causing this point wrangle to be run on the piece again, we don't want to store a later frame for the reshatter time. Whatever that first shatter frame is, we want that to be stored and never changed after that. So it looks like we have shatter frame being computed correctly. But yeah, it looks like this is only running on our, it looks like this is not persistent. How do we get this? Because basically anything we change here seems like it's not sticking on our geometry. It seems like it only changes temporarily. Let me just rename these: detect impacts, process collided. Now let's see if we're missing something obvious. Yeah, I might have to get back to you on this, on how to make it persistent. At least we're a good portion of the way there in terms of detecting the impacts. And we should be just a small step or two away from getting these persistent impacts to be stored. Basically, the way this is ultimately going to work at the end is once we get that bullet ignore and the shatter frame to persist on the geometry and for those attributes to stick after we detect this, then after our simulation, I'll just add a couple splits to, or I'll add a blast just to show you what you would do. So we can say blast, and then we'll say at bullet underscore ignore equals 1. And this will isolate all of the bullet ignore objects. So that will isolate collided. And then we can use another blast. And for this bullet ignore equals 1, that group type will have to be points because that would be a point attribute. And the second blast will check the shatter frame. Actually, we could do this all in one probably. I'll say bullet ignores 1 and shatter frame equals the current frame. And flip that to delete non-selected. So then after this initial sim, this isolate collided blast will give us at each frame the object that has hit and that is supposed to reshatter at that frame. And then when that happens, since we have this isolated piece, like let's pretend that this box here is, oops, we don't need to connect that there. Let's say this was just a piece of glass that's reshattering. Make that slightly more convincing by doing that. Let's pretend that's a glass shard. Then you can just do the same thing we did before for instancing some pieces onto that. You would just scatter some smaller glass shards here and give that some velocity, and then run that as a secondary sim to have these emitted RBD, or it could be pops, I suppose. It could be anything you want. Just scatter an extra source based on each of those colliding objects, and you could emit RBDs for some smaller glass shards that this breaks into. It could be a puff of dust. It could be sparks, if that makes sense for your shot. Probably doesn't make sense for a glass shard to emit sparks, but you never know. They ask for crazy things sometimes. So yeah, I guess with the last several minutes we have, since we started slightly late, I'll go a little bit over time here. But I'm just going to, actually before I continue to explore how to make that persistent, I'm just going to copy some of these bits of code into the chat box. I just sent what I think the correct group syntax would be to isolate each of the current reshattering objects. And let me just paste in the code we came up with to detect the impacts as well, just in case it's hard to see in the video. So this would be primwrangle detect impacts. And I'll paste the process impacts code in as well. Point wrangle process impacts. Okay. Now I think the key for getting this to persist might be the feedback here, though I'm not sure. Let's double check the DOP import records help to see if that's going to give us any clues. Option field vector. Let's see, maybe There's some options to get the feedback working here. Well, no, I guess that wouldn't make sense for the DOP import. We could try to do something with the wrangle. Let's try, I'll add a geometry wrangle after the SOP solver, because I'm curious if those new values are available in the geometry wrangle here. Let's set this to, run on, let's run on points. Maybe we'll query one of these point attributes here. Oops. Maybe in the geometry wrangle, I'll give the pieces a big y velocity just to see if we can detect the impacts after the SOP solver. So I'll say if I at bullet ignore, which this shouldn't make sense because we shouldn't be able to do anything sim-wise to pieces that have bullet ignore specified, but I'm curious to see if this will do something. Right now we're just investigating and debugging to see what's going on in our sim. And really good effects work isn't a matter of knowing how to do everything. It's a matter of figuring out why things aren't working. So no matter how long you've been doing effect stuff, you'll run into problems where things aren't working the way you expect all the time. So yeah, don't expect to know anything, just expect to need to debug all the time. So it looks like this geometry wrangle is seeing that bullet ignore attribute on our geometry. And unfortunately, it doesn't seem to be respecting it. Let me just do a sanity check on our RBD packed object. It is just bullet underscore ignore, right? Yep, it's just bullet ignore, it's an integer. It's very strange. We are setting that. It is being seen as bullet ignore by the wrangle. Maybe we can, maybe the object order does matter. Let's try putting the SOP solver first and the geometry wrangle after that. I'm guessing that when we put the SOP solver before the bullet solver, we might not have those impact records available here. It looks like we still have something available. Yeah, I may have to get back to you about this one in next week's session and or on the forums. I think we went over some very good stuff in this session though, just learning a little bit about filtering out that impact data and doing some custom stuff based on that is kind of a big deal. I wouldn't say you need to use impact data very often, but when you do need to, it can be quite helpful. Particularly for these reshatter effects or creating sources for doing lots of secondaries based on one object dying in your sim. Oh, come on, this view bug is terrible. Yeah, I'll just tinker with this for a few more minutes, but so no more questions. Cool, that's all good. No problem, you're very welcome. Yeah, hopefully we'll get this working because these reshattering setups are pretty cool. I think I'll just call it a night for now, or afternoon, depending on where you are. and I'll let you know what the missing link is for this setup in the next live session. So yep, good luck with this week's material, and I can't wait to see everybody's updates.